Okay, okay. Good evening, everyone. Myself, Dr. S. Vasundhara, Assistant Professor of Mathematics, Department of Humanities and Mathematics, G. Narayanamma Institute of Technology and Science, Hyderabad. So, I have some knowledge about Indian knowledge system perspective to mathematics. With my perspective, I can share something about Indian knowledge system, how it is changes from ancient mathematical literature to now. So, for thousands of years, India has been a hub of mathematical innovations, producing renowned mathematicians and astronomers who have shaped our understanding of the world from the ancient Vedas to the groundbreaking works of famous mathematicians. Indian mathematics has made significant contributions to geometry, algebra, trigonometry, and many more. So, here we can have the key concepts and contributions and influences on modern mathematics and science. So, systematic transfer of knowledge from generation to generation, it is not a simply a tradition, but well structured system and process of knowledge transfer, and it is vast knowledge system. So mathematics in India has a very rich, long and hallowed history, starting from the most elementary things in mathematics, namely the representation of numbers through the way of expressing recursive relations to arriving at the solutions of indeterminate equations to the development of sophisticated techniques in handling the infinite, and the infinitesimal Indian mathematicians have made remarkable contributions to our Indian mathematical system. The concept of shunya, the revolutionary zero and the decimal system, here the concept of shunya, meaning emptiness or void, was revolutionary, and it evolved from a placeholder in positional rotation to a number in its own right. This abstract idea transformed mathematics by allowing for the representation of absence and enabling more complex arithmetic operations, and its introduction was a paradigm shift in numerical thinking. Here, the mathematical modeling here to take that hands in with the zero came the positional decimal system. The system using base 10 mean that the value of a digit depends on its position between a number and different from 2 in 200. This elegant system dramatically simplified calculations and making the mathematics accessible and efficient. So this is developed by Indian mathematicians. The formalization of zero as a both a placeholder and a numerical value is attributed to Indian mathematicians around the 5th century only, with notable contributions from figures like Brahmagupta in 7th century, who established the rules for its arithmetic operations, and this intellectual leap was unprecedented in other ancient civilization also. Now the transformation of arithmetic, the combined power of zero and the decimal system utterly transforms the arithmetic compared to cumbersome system like Roman numerals, which lacked a zero and positional value. The Indian system offers the unparalleled ease and flexibility for large numbers and intricate computations. It laid the foundations for all the subsequent numerical advancements. Now, coming to the place value and the notation, the Indian place value system using only 10 digits, which was masterstroke of mathematical efficiency, and the system assigns a value to a digit based on its position within a number, make it possible to represent any quantity no matter how large with a minimal set of symbols. For instance, say the digit 5 holds a vastly different value in 500 compared to 50 or 5. Simply the virtue of its placement, and this innovation elimination the needs for cumbersome unique symbols for each power of 10 and simplifying both writing and computation. This elegant notation method allows for the efficient representation and manipulation of extremely large numbers uh, to can be which can be applied with only the 10 digits and the other advanced mathematical pursuits in ancient India. Furthermore, the binary system, which forms the core of modern computing, that is a direct descent of the positional principle, the concept that a symbol can be representing different magnitudes depending on its position, and it's fundamental to how modern computer stores and process the information. The ancient Indian insights into a place value remains a cornerstone of both theoretical, mathematical, as well as the practical digital technology today. Now, coming to the famous Indian mathematician, what is the contribution to our mathematics? Aryabhatta is the master of astronomy and trigonometry. Here, Aryabhatta was a prominent Indian mathematician and astronomer. He made significant contributions to the understanding and formalization of shunya, that is zero, as both a placeholder and a number its own right. While the concept of a placeholder zero existed before Aryabhatta, he was instrumental in defining zero as a digit within the decimal place value system. He used zero in his place value system, allowing him to write large numbers more efficiently. Furthermore, Aryabhatta laid the groundwork for understanding zero's properties and applications in arithmetic operations, although a complete axiomatic treatment would come later. His work, particularly the Aryabhattiya, which demonstrates a sophisticated understanding of zero's role in mathematical calculations. The Indian decimal system is one of the most significant advancements in mathematics, fundamentally changing how numbers are represented and calculated. Originating in ancient India, this numeral system laid the groundwork for modern mathematics and influenced various scientific fields. So here exploring the history like notable mathematicians and peer reaching the impact of mathematics and science. Now, in this way, he used the trigonometric function. Aryabhatta was among the first to define the sine and their sign, like Rya and Cojia functions, which are critical in the study of triangle and circular motions. These concepts were fundamental for his astronomical calculations and laid the groundwork for modern trigonometry and approximating the value of pi, also given by the mathematician Aryabhatta only. He calculated the pi to an impressive four decimal places like 3.1416, stating that the ratio of a circle's circumference to its diameter is approximately this value. And he also suggested that this value was incommensurable irrational number. And he gave that these details of the sine table, and he developed the earliest known details of sine tables, providing the values for various angles. And these tables allows for unprecedented accuracy in astronomical and geometric calculations, a significant leap forward from the previous methods. Earth rotation and eclipse also, he gave the correct measure theory that that the earth rotates on its axis, causing the apparent movement of stars. And Aryabhatta also provides accurate explanation for solar and lunar eclipse, challenging prevailing mythological beliefs. Coming to another mathematician, Brahmagupta, which is from 598 C to 668 CE, pioneering algebraic. 'algebrist. 'algebrist' 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 Here, the development of the decimal system in Brahmagupta, who expanded upon Aryabhata's work in his influential text, which is known as Brahmaputsadayinta. He introduced the rules for operations involving zero as well as the negative numbers, further developing the arithmetic principles which are necessary for the decimal system, and Brahmagupta work on fractions and geometry also contributes significantly to the evolution of mathematics in India. He had that arithmetic operations like define zero as the result of subtracting a number from itself and provided clear rules for addition, subtraction, multiplication and division involving a positive, negative and zero quantity. And he gave the solutions for quadratic equations as well. He presented a method here for solving a quadratic equation including the cases where negative solutions arose, demonstrating an advanced understanding of algebraic principles that predated the European mathematicians. And he proved the cyclic quadrilateral famous for the area of a cyclic quadrilateral, that is a quadrilateral whose vertices lie on a single circle. This formula is generalization of Heron's formula for the area of a triangle, showcasing his geometric powers. Influencing on Arab scholars, his work were translated into Arab, particularly the Brahma Puskadinta, which becomes the highly influential among Arab scholars, and this transmission was crucial for the eventual spread of Indian numerical system and algebra concepts to the Western world. Bhaskara was also the mathematician. He has the calculus precursors and number theory. He was there, known as the Bhaskara the Great, further advanced the Indian decimal system and mathematics in general. His seminal work, Siddhanta Shiromani, which addresses various mathematical topics including algebra, calculus, and the properties of numbers. His contributions to understanding the concepts of continuity and the use of infinitesimals in calculus, showcasing the advanced nature of Indian mathematics. So here the Indian mathematics, the Indian decimal system did not remain confined to the subcontinent. It spreads to the Islamic world through the transition of Indian texts during the golden age of Islamic thought here. His work Siddhanta Shiromani, he explored the concept of instantaneous rate of change and the derivatives which are fundamentals to differential calculus. Nowadays it is having very good applications and the traveling of a car and his applications which are having significant role in engineering mathematics like applications of differential equations to different initial value problems as well as the boundary value problems. He uses these ideas to calculate the instantaneous motion of planets and to find the turning point in functions centuries before Newton's and Leibniz. Our third key transforms here. Bhaskara too has several influential mathematical texts. Leelavati is the treatise on arithmetic presents in a poetic style with the problem posed to a princess. Bija, Bija Ganita focuses on algebra, while Siddhanta Siromani is his main astronomical treatise, incorporating his advanced mathematical insights. He made significant advancement in the study of infinite series and he provided a sophisticated method for solving Pearl's equation, which is a type of Diophantine equation known as the Chakravala method or cyclic method. This was highly advanced technique for his time. So he made a significant contributions in number theory, which gives the fruits now what we are enjoying in the cryptography, which is advanced topics in computer science nowadays, like cryptography in the sense while securing the information from one place to another place, it means have lot of attributes like authentication, maintaining the secrecy, confidentiality. These are all the things can be having with the main concepts of number theory only. While sending the message from one person to another person, if there is any eavesdropper, third person can access the message by taking different types of codes. Instead of that, using this elliptic curve cryptography, they had two keys with the main person who is sending the message to receive a person. With the access of the plain text only, that person can access the message, and there may be the no chance of the eavesdropper can see the message. In that case, he had a lot of contributions, and maximum part should be with the help of the number theory only. And advanced astronomical observations, because in his Siddhanta Shiromani also contain detailed astronomical observations and calculations, which are including planetary longitude, solar and lunar eclipse, and the determination of planetary periods, showcasing his expertise in both theoretical and observational astronomy. His contributions to mathematics are works with the number zero, the sign function, approximate value was given by him, and the numbers in the Hindu decimal system was written by him. He is having the numbers in the positional way, and the Aryabhatta was refined the works, and he and the Brahmagupta have contributions to the study of fractions and Pell equations even before Pell gave the name to it. We have one more, the Kerala School of Mathematics. Here, the Kerala School of Mathematics, coming to that, known as the Kerala School of Astronomy and Mathematics, represents one of the most significant yet often overlooked contributions to the global history of mathematics, flourishing between the 14th and the 16th century. This school of thought was rooted in the southwestern state of Kerala, India, and produced a remarkable body of work in mathematics and astronomy that predated many similar developments in Europe by centuries. The Kerala school emerged during a period of intellectual vibrancy in the region, supported by a rich cultural and scholarly tradition. With its thriving trade routes and connections to other parts of the world become a melting pot of ideas, scholars in Kerala were well versed in Sanskrit and had access to ancient Indian texts, including the works of Aryabhatta, Brahmagupta, and Bhaskara. This intellectual environment fostered the growth of a mathematical tradition that would have far reaching implications. The most notable figures which are associated with this Kerala school is Madhava of Sangamagrama, often considered the father of mathematical analysis. Madhava is made the contributions of groundbreaking contributions to the laid a foundation for calculus centuries before it was formally recognized in Europe. He developed the infinite series expansion for trigonometric functions such as sine, cosine, and arctangent. His work on the value of pi is particularly noteworthy. He devised a series that approximate pi to an extraordinary degree of accuracy. So, to that Madhava, a lineage of scholars continued his work, including Nilakanta Swamiji, Jeshtadveva and Achyuta Pishtari, Neelakanta Somayaji, renowned for his work on planetary models in his treatise Tantra Samgraha, his revisions to the tradition geocentric models of astronomy, which anticipated the certain aspects of helicoidal models and demonstrate the school's advanced understanding of celestial mechanism. So, in the Jetadhyaya Yukta Bhasha, written in Malayalam, which is another key text from this period, which is considered one of the first texts to systematically describe the mathematical derivations of the Kerala school, providing insight into the understanding of calculus and mathematical proofs. He developed that sine and cosine series expansion, and he gave that Leibniz series for expansion of the phi and European calculus. His work on influencing the series and convergence for predated European mathematicians like Isaac Newton and Gottfried Wilhelm Leibniz by approximating 200 to 300 years. It is highly sophisticated understanding of calculus which are related to including the notion of limits, convergence, challenging the traditional narratives of calculus' sole European origin. Now, the Kerala school approximately approaches to mathematics, which is characterized by a blend of geometric and algebraic methods, which employs a rigorous logical structure in their work, which was often presented in the form of proofs, solutions, which is the method that was not common in Indian mathematics before this period. The scholars of Kerala, which are also made extensive use of iterative methods, infinite series, and calculus-like concepts which they applied to problems in trigonometry and astronomy. One of the most significant achievements of Kerala school was the work in the infinite series, Madhava series for pi, and the functions demonstrating an understanding of convergence and the concepts of limits, which are fundamentals to the modern calculus. These series are expressed in a format that resembles the Taylor series expansion used in our modern calculus, which are expanding any function containing a single variable or more number of variables which can be expressed in infinite series to check whether the function is having the property of convergence or divergence, which can be expressed in either Taylor series expansion or Maclaurin series expansion as well. So, indigenous mathematical problem solving approaches in that Indian mathematics emphasized the holistic practical approach to problem solving, focusing on real world applications and addressing the challenges within the specific context. Here, the legacy and the influence here, the groundbreaking contributions of different mathematicians, whether they are unknown to outside India for centuries. One reason for this was the geographical and cultural isolation of Kerala, because the many contributions are developed from Kerala, even though they remained relatively unknown to the outside India, for the reason that the geographical and cultural isolation of Kerala, which is limiting to the spread of these ideas to other parts of the world. Additionally, much of the work of Kerala school was written in regional language such as Malayalam and Sanskritam, making it less accessible to the scholars outside India to access the theory and proofs. However, the intellectual legacy of the Kerala school has gradually gained recognition in modern times, and the rediscovery of the text like Yukti Bhasha and the recognition of the Kerala schools advancements have led to revaluation of the history of mathematics. The contributions of Madhava and his successors are now seen as a crucial chapter in the global history of the mathematics, which is highlighting the diverse and interconnected nature of the mathematical development. Coming to the impact of this, our present trend, the transmission to other culture, which is influencing on Islamic mathematics during the Islamic golden age of 8th to 14th century, many ancient Indian mathematics, the mathematical texts were translated into Arabic. Transformation introduced the Indian mathematical concepts such as zero, decimal system, trigonometry, algebra to Islamic scholars. Figures like Al-Khawarizmi, often referred to as the father of algebra, incorporated these Indian contributions into their own works, which were later transmitted to Europe, influences on European mathematics as well. Coming to the transmission of Indian mathematical knowledge through Islamic scholars, which plays a crucial role in the development of European mathematics during the resonance. So, Indian numerals, often called as Arabic numerals, in the West, due to the transmission through Arabic texts, replaced these Roman numerals, revolutionizing arithmetic and algebra calculations. The introduction of Indian mathematical concepts, which are including zero, trigonometry, functions, spurred advancements in European mathematics, paving the way for the scientific revolutions. Here, the approaches were characterized by adaptability and the flexibility, allowing for diverse perspectives and creative solutions, which are leads to the complex mathematical problems. Now, comparing the Indian mathematical methods to the Western approaches, it is having the understanding of intuitive reasoning, which are practical applications, while Western approaches sometimes prioritizing the formal proofs and abstract concepts. And different notation system is also having, including the place value notation and the use of symbol for zero, while Western mathematics evolved its own distinct symbols and methods representation. If the people are evolved with that number theory and data related to, maybe the data is in the form of a text or in the form of a message or in the form of a numerals, which can having a lot of significant role nowadays compared to the olden, because the data what we are generating now is numerous data is generating every second. Thousands of gigabytes of data is generated. Until and unless if the data is, until and unless if the data is used for a different purpose, like analysis of the data or simplifying the data for getting, which can be given for better accuracy about the data, like data can be collected or data can be given for a better predictive model, unless and until if there is a significant contribution related to the data, there is no use of this data can be modified. So here, analytics plays a crucial role in many engineering problems, like the people who are studying the data, which can be pre-processed and applying the different types of machine learning algorithms, which can be rolled to the predictive model, can lead to the real world application. While the data is generated, it can be in the form of, I told you, it can be in the form of a text, in the form of a message, or in the form of a numeral. There, it is having different contributions related to the computer science engineering nowadays. The data is transformed, whether you can have the security of the data or you are applying different types of machine learning algorithms, like it should be in the form of a supervised learning, unsupervised learning, or reinforcement learning, after applying different types of algorithms to the data, which we are leads to a predictive model about the data. Then only the contributions of the data can having a significant role. So what are all the contributions made by different Indian mathematicians which we are enjoying the fruits nowadays? Now here, the global impact and the transmissions adapting that Arabic scholars, which is spread of advanced mathematics beyond just numerals, the Indian advancement in algebra, trigonometry, and algorithms thinking also spread. Arab scholars translated and expanded upon Indian texts, surviving as a crucial intermediary in the transmission of this knowledge to the Western world. Fibonacci's Liberabacchi, the renowned Italian mathematician Fibonacci, after studying in North Africa, introduced these Arabic numerals which were originated India to Europe in his influential book Liber Abaci in the 13th century. And this book was demonstrated the practicality and efficiency of the new system leads to the applications in computer engineering nowadays. Now, the catalyst for scientific revolution, the adoption of the Hindu-Arabic numeral systems, which inherent the efficiency was a critical factor in the European resonance and the scientific revolutions. It simplifies the complex calculations, enabling the advancement in astronomy, physics, navigation, and engineering that would have been for more difficult with older numerical systems. The contributions of different mathematicians like Lilavati Bijaganitam and Sierra, which is having a different contributions to that, leads to the corresponding what we are enjoying the things today. So, legacy of the modern mathematics in science, the ripple effects of ancient Indian mathematical discoveries are still profoundly felt in contemporary mathematics and science, forming the very bedrock of our digital world and scientific industry. So here, digital foundations, the binary system fundamentals to all modern computational system and the digital technology relies entirely on the principle of place value and the concept of zero, both pioneered in ancient India. Uncovering the lost knowledge, ongoing the research into historical Indian mathematical texts continues to yield new insights, occasionally revealing advanced concepts that were either lost or not fully understood until the modern time comes. Algorithmic roots also having used in contemporary computing and data processing have conceptual roots in ancient Indian mathematical techniques, particularly these related to arithmetic, algebra, and number theory. In the coding system, we can have significant role of number theory in cryptography and network security. While applying this number theory concepts in cryptography, large amount of data is there. It will take more memory to occupy, and there may be a chance of confidentiality can reveals to others. Instead of that, if you want to use that elliptical cryptography, less memory with more authenticity should be there. In that, the key features all are related to the number theory concepts only, which is given by our famous mathematician Srinivasa Ramanujan. Inspiration for the future also, the rich heritage of Indian mathematics serves as an inspiration for contemporary Indian mathematical research and education, fostering a sense of pride and encouraging the new generation to pursue scientific innovations, recognizing this legacy vital for a comprehensive understanding of the global history of science and technological investments. So coming to the conclusion here, since we are in the age of digital era, what are all the contributions made by our famous mathematicians Aryabhatta, Brahmagupta, Bhaskaracharya, Srinivasa Ramanujan, and C.R. Rao Institute of Advanced Science and Mathematics, Statistics and Computers, which is there in Hyderabad, nearer to University of Hyderabad. He, sir, was also made contributions. In most of the contributions are given by Melbourne's distance, and statistical contributions are there. Even there, most research is happening related to statistical contributions here. So even we are in this digital era, we want to check what are the significant contributions made by our Indian mathematicians, what are all the applications, what are the fruits we are enjoying, so that it can be come to the every nook and corner of the people in that entire India, not only India, in the entire world. Then only the applications, the contributions, what are all the research related to the applications of planar system, solar system, and the rotation of the sun, moon, and calculations of the angles. These are all the things, and learning the Sanskrit, because Vimana Shastra, what we are enjoying here, know the language correctly in the Sanskritam, what are all the contributions which they did before may be born also. The researchers, the young researchers are have to check the applications, what they discovered and what we are enjoying, and how to implement to the present situation, which leads to the real-time applications, so that every person can have correct idea. In Vedic mathematics also, like school children, they can really have the afraid of mathematics is like a different subject, or which is a difficult subject, like something should there in their mind. If we are inculcating the habit of Vedic mathematics, introducing how they can do the easy addition, calculations, multiplications, and 2 by 2 digits or 3 by 3 digits. If we are introducing at the age of school level only the Vedic mathematics, which makes a contributions to our real world situations. The civilization to the mathematics are not merely significant, they are foundations to the global scientific edifice, from the revolutionary concepts of zero and the powerful decimal place value system, which underpin virtually all modern calculations, to sophisticated advancements in algebra, trigonometry, even the persistent development of calculus concepts, and ancient Indian mathematical demonstrated an unparalleled depth of inquiry and innovations over millennia. There is no doubt without India, the world would know mathematics as we know it today. Without India, there would be no mathematics as we all know it today. The transmission of these ideas, particularly through Arab scholars, plays a pivotal role in shaping the mathematical landscape of the medieval Islamic world, and subsequently support the European resonance and the scientific revolution. Recognizing the Indian knowledge system in mathematics not only provides a more accurate and inclusive understanding of the history of science, but also highlights the interconnectedness of the human intellectual endeavors across the different cultures and eras. It is a treatment to India's enduring legacy as a powerhouse of mathematical thoughts. With this, I'm concluding my talk. Let me know, is there any doubt?